in this particular lesson, we'll be doing a lot of problems which usually comes in entrance exams like NEET UG or JEE mains, JEE advanced, or the state level entrance exams and all. So basically, we have to, should have some expertise over the concepts that we have already come across in Coulomb's law, electric field, dipole moment, torque, and everything. So whatever concepts that we have already learned and already gone through the section and the chapter and whatever knowledge base we have to apply those concepts, those formulae, those knowledge and those things for solving problems. That usually comes in entrance. So that is what the motive of this class. So we are dealing with the problems which is exclusively meant for this exams that I already mentioned. And please have your class with copy ready. And one more thing I should tell you, that is that today we are, nowadays we are going through a very bad phase of the mankind. The whole world is suffering from COVID-19 and it's going for a very worst scenario right now. But don't panic and don't waste time. Since you have ample amount of time, you're sitting at home, you have locked in home, we have lockdowns, but that is also a span of time we can actually prepare ourselves for your 2021 exams. So stay back at home, utilize the excess amount of time you have right now, complete the things that you have done in class 11, you revise those things again, so that you have good amount of concepts, because later on when the school reopens and everything goes normal, then they will rush. So you will have very less amount of time, you can understand that. So be aware of those situations. And again I'm telling you, stay at home, utilize your extra time and invest this extra time to improve yourselves. Okay, so right now there will be a problem coming up and we'll be solving this. Okay, best of luck. Now here is the problem. They have mentioned that the total charge of minus capital Q is uniformly spread over a ring of radius capital R. A small test charge small q of mass small m is kept on the axis of the ring and is given a gentle push. This is very important, this is interesting. We have given a gentle push to a test charge small q, which is resting on the axis of the ring, and we have to describe the motion. This is the problem. Written the problem in your class book, I hope. So here is the arrangement. We have a ring lying on the xy plane as shown in the axis system on the right side. You can see, I hope. So we have minus q charge distributed over the ring, and we have a small q charge located on the axis of it, and we have also drawn the direction of electric field, which is downward because the negative charge minus q, and also the direction of force, which is along minus z axis or minus k cap. So this is the thing. Now we are going to solve this problem. Draw this diagram in your class book. One thing, this is a ring. We have a point where the small q is located. We have to find out what is the electric field. We know what is the electric field due to ring distribution of charge or a rod and all these things we have already done. So we can easily write the expression. Here the direction of the electric field is downward. You can understand why, because it's a negatively charged ring, so obviously the electric field towards. So the force will be also towards, because this is a positive charge, negative charge, they will attract each other, simple thing. So we can directly write the electric field due to this ring distribution of charge, which is 1 by 4 pi epsilon naught qz. If I assume that this distance is z, then qz by r square plus z square whole to the power 3 by 2 minus k cap is the direction downward. Great. So what is force now? Q into E. So q into small q into E. So capital Q small q z by 4 pi this thing. The same thing is here. Now you have given this to be given a gentle push, and this is a ring and it's not very far. So we can easily assume that z is much smaller than capital R. So obviously r square plus z square will tend to r square itself. So what is the limiting value of the force? Because we have taken a limit here. So what it is? It is capital Q small q z. I am taking the minus here. K cap is the direction, no issue. And what is the thing? 4 pi epsilon naught r cube. Okay, great. So this capital Q, small q is given. We know the amount of charge and they are constant. 4 pi epsilon naught for vacuum is constant, and capital R cube. So R is also a constant because it is having a finite shape for the ring. So this capital Q, small q, 4 pi epsilon naught R cube, this whole thing is a constant. So force is inversely proportional to Z, displacement. This is SHM, simple harmonic motion. We have got this idea. Fine. So we can say this is SHM. This is simple harmonic motion. Great. So what is the acceleration of that? What is omega here? You can understand. Omega square and all. So omega is square root of capital Q, small q by 4 pi epsilon naught capital R cube. This is omega here. Square root now. Okay? Great. So what will be the time period for this particular motion? 2 pi by omega. So we can easily find it out. There is another thing. This is force. So in order to find out omega, we have to divide it with by m. I'm sorry. So please rectify this. I'm sorry. I actually directly wrote the value of omega from force, but actually it should be acceleration. Acceleration is minus capital Q small q z by 4 pi epsilon naught m r cube and k cap. So from here we can write this. Very good. So what is the final form for the time period? Is this, So quite interesting. We are getting a simple harmonic motion out of this arrangement. Isn't it very, energetic? We are getting some concepts which is simple harmonic motion because of this expression. Okay, sure. So this is the thing. They asked us describe the motion, and we have described everything of this motion. Right? We know what it is. Simple harmonic motion, and the rest of the characteristics we know. Okay? Now we will get another problem in front of you. Okay? Copy that in your classwork, then I'll solve again. Here is the second problem, all of you. Now we are interested to find out the electric field at a point which is on the perpendicular bisector of a rod carrying a charge capital Q, and the length of the rod is 2L. You can see. So they have mentioned that this rod is having a linear charge distribution of lambda. Okay. So we have to calculate the electric field at D, and we have drawn the diagram. Please draw this diagram in your classwork, and then we'll solve this. Okay, so now we have understood the situation. We have to calculate electric field at point D due to a long uniform wire of certain length, L to L, whatever. But the interesting point is that this particular rod is having a linear charge wire is having a linear charge density of lambda, that is they have given. So let me try to generalize the things. So for that reason we have drawn all these things, and all fine. We have DE. So for DQ we have DE, and we have taken an elementary section DL on the wire, and we have taken a charge of elementary section is DQ. So the elementary electric field is DE. This is first we have to understand. Great. Now what we are going to do next is, suppose we have L, R naught, theta and everything. So we can write L equals to R naught tan theta. So DL, since we have a differential form and we don't know the exact charge, we have to calculate everything with respect to lambda because they have given the linear charge density. Great. So L equals to R naught tan theta, DL equals to R naught sec square theta d theta. We are differentiating. Great. So we are writing DE. What it will be? Lambda DL, because DQ is lambda DL. As per the definition of lambda, okay, 4 pi r square, 4 pi epsilon naught r square. Great. Now what is r square? Is L square plus r naught square that I have written in the bracket. Okay. So now I am going to replace DL here, this particular the value of DL here, and also we are going to write L square is R naught square tan square theta, and R naught also there. So I am taking R naught common. So the remaining thing, which is 1 plus tan square theta is sec square theta. So we have taken this because these two will get cancelled. Finally we have an expression D equals to lambda d theta by 4 pi epsilon naught R naught. Great. So this is now we have formulated. Remember this expression. Now as you know that this is the symmetrical figure, up and down, there are two ways. So DEY, this component, for this the electric field will be like this and the DEY will go reverse. So everything upward will cancel everything downward. So DEY, this component will ultimately get vanished. It won't be there. So what will remain? The remaining part will be this. Because all the components along x-axis, even for the lower part, will be like this. Along the direction of what we say I cap. Great. So for we have to write here, so the net field is dx. And what is that? Obviously you can understand. It is lambda d theta cos theta by 4 pi epsilon naught r naught, and of course the I cap indicating the direction along positive side of x-axis as per our unit vector notation. So this is what we have done. Now what is the next thing? We have to integrate. Now what I am going to integrate? I am going to integrate, since if I assume this theta if it is going far and far below, so the maximum value is plus pi by 2 and the minimum value is minus pi by 2. So we'll start from below till up. So we'll write here minus pi by 2 as limit and plus pi by 2 as the upper limit. And the rest of the fact what we have, we are just taking the magnitude. So lambda d cos theta, lambda cos theta d theta by 4 pi epsilon naught r naught. As you can see, this lambda 4 pi epsilon naught r naught, everything I can take out outside of this integration, because these are not integratable, integrating things. We have to just integrate cos theta d theta and put this values, which we can easily find out. It will be cos theta d theta will be sin theta plus pi by 2 sin pi by 2 and minus sin pi by 2. The both is plus 1 and minus 1. So when we will subtract, this will become 2 and here is 1 4. So you can actually tell me the value. You can actually tell me the value. You can tell me the value of total electric field summing up all these DEX will be lambda by 2 pi epsilon naught r naught and I cap, showing the direction of this electric field. So this is the value. This value lambda by 2 pi epsilon naught r naught is very interesting. Here you can see, usually what you have seen till there, electric field is usually inversely proportional to r square. Now you can see that it is inversely proportional to r naught or whatever we say. So that means here is an interesting result. This result will again come up in our next lesson when we do Gauss's theorem. Okay, so then you will understand more. But right now, this is the problem. We have solved the problem and we have got the expression for this kind of electric field. This is very, very interesting. Do copy this and do practice this. A lot of time this will help you for your JEE mains, JEE advanced and other NEET, UG and other engineering or medical entrance exam which happens all over the India. Okay, now here comes the problem number 3 and it is very interesting again. It's based on dipole. Okay, so recollect. So what they have given, that there is a dipole, which is like this. There is a dipole which is lying in a uniform electric field and in this fashion. Now we are actually rotating this dipole and we want to know that if we are giving a small push, then what happens? Already we have solved a problem like in SHM which exhibits SHM, no? Okay. So if it is like we have displaced the dipole by some angle theta and then it is making an angle theta. So what is the torque? The torque is definitely the restoring. So it is PE sine theta, and when theta is very small then sine theta tends to theta, so that gives me tau equals to minus PE theta. Okay. So what is tau? According to the concept of rotational motion, the moment of inertia concepts, that those things, the tau is actually this. Actually it is I alpha and alpha is this. So we can actually, you see, we can write this expression. Alright, so what comes next? What I can say is d2 theta dv square is equal to minus pe by I this whole into theta. So again, perhaps I need not to even tell you that this is again what? SHM. Yes, great. So SHM again, and this is omega square. So what is omega? Omega is PE by moment of inertia of this system. Assuming the charges, they have masses, whatever small that may be, but they have masses, so they have moment of inertia. The system has a moment of inertia. So we have this. So what is the final time period of this particular motion? You can easily write. So this is the time period. So we have solved this problem 3, okay, which dealt with the dipole and its motion, and how we can exhibit that if a small push is given to a dipole in a uniform electric field, it will exhibit simple harmonic motion. Okay. Now we have two small dipoles here. You can see we have two small dipoles which are located in this fashion, P at 0, 0, 0, and it is directed along positive z axis, and P by 2 at 1 meter, 0, 2 meter, that is on xz plane axis actually, and we have to find the field due to these at 1, 0, 0. This is the problem. So let us go for the solution. First, we have to understand the very one thing, and that is the diagram. You see, we have three axes. We are omitting y axis because they have not given any y coordinate. You can see in the sum. Okay, you can see there is no y coordinate, even not at the point where we are going to find the electric field. So here it is, and we have one dipole at O directed towards positive z axis, one dipole at A, and same way. So when we want to find out the net field at D, the located point 1, 0, 0, here it's very interesting. It is the point which is the equatorial point for the dipole at O, and it is a point which is on the axis of the dipole A. So we have the formulae for the particular small dipoles along equatorial or axial points. So now it comes. There is the solution. So we are calculating the two electric fields due to these two dipoles. That's minus k. K means 1 by 4 pi epsilon naught. Kp cube by 1 cube plus k into 2 into p by 2 whole cube by 2 cube here, and directed along k cap, and finally we are getting an expression which is minus 7p by 32 pi epsilon naught k cap. So the effective electric field will be downward. So whatever convention we have, just the vector addition. So this is the final answer, 7p by 32 pi epsilon naught k cap, and it is minus. Okay. We are moving into problem 5. This is very interesting. Two concentric rings having centers O at O. Two concentric rings having centers at O, origin. Within first bracket, write origin after O. Contains total charge capital Q and minus root 8 Q, whose radii are capital R and 2 capital R respectively. Find a point on the z-axis where the field due to this total system will be 0. We have to find the distance OP. This is what we have to find. Written? Okay. So we know that the point P, the electric field is 0. Great. So what is EP actually? 1 by 4 pi epsilon naught we are taking common. So we have Q, capital QR, this distance, and then the axis formula. So r square plus capital R square whole to the power 3 by 2 minus, since this is a negative charge, the field will be downward, so minus k cap, so root 8q small r by small r plus 4 capital R, since this distance is 2r, the outer radius, so it is 4 capital R square whole to the power 3 by 2 k cap, and that is equal to 0 because we know this, they are given. So you can understand, now this is equal to 0, right? So if this 2 equals to 0, then everything will get cancelled, you can understand, whatever will remain afterwards, and we can actually calculate the value of r, which is equal to root 2 capital R. Okay, so we have got this distance we have calculated, it is root under 2 capital. Okay, so we have another problem 6. What they have given a regular hexagon, and they have placed 6 charges, one on all the vertices and on the points. So what are the charges? Q, 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 then minus Q, minus Q, minus Q. Fine. Now we want to know what is the total electric field at a point on the perpendicular axis of the thing, of this hexagon, and we have to find at a point x. From O, the distance is x, but it is on the line which is perpendicular to the plane, and somewhere at point x. And they have also said that x is much greater than A, where A is the side of the dipole. These are the things they have given. So you have to find the electric field at this point, and if we want to write this electric field, let us solve it. So what I am going to write, the electric field will be equal to, you can see the dipoles here. Can you see the dipole this and this, the dipole this and this, and the dipole this and this, and we are calculating it at a plane which is somewhere here, right? So for this dipole, you are getting a field like this, anti-parallel kind of thing, parallel kind of thing. Another one you are getting this way, another one you are getting for this dipole, you are getting this way. So your electric field diagram is like this. There is one E, there is one E, there is one E, which all are inclined at 60 degree. We are taking a plane which is just a plane parallel to the plane of this hexagon. Sure. Okay. So what I can write? I can write E equals to, easy. I can take the resolution, and this sine theta will cancel. So only cos 60 remains. So I can write E cos 60 plus E cos 60. And what is E? We know it is the equatorial point. There is a small dipole, as it suggests that it is a small dipole as compared to the point where we are calculating the electric field. So finally we are getting, it is E by 2 plus E by 2, cos 60 is half. So total electric field, say EP or something, whatever you say this point. So EP is equal to 2E. And what is E? E is 1 by 4 pi epsilon naught. What is it? P by x cubed. P is the dipole moment here. So what is the dipole moment here? Dipole moment here is, so final answer we are going to write 1 by 4 pi epsilon naught q into 2a, this distance, you know this is 2a from hexagonal properties, okay, by x cube. So finally what I am getting, 4 is getting cancelled, qa by pi epsilon naught x cube. Just remember this is the expression, we have got the answer. Now we have a very interesting problem which came in AIEEE. I mean JEE mains was previously known as AIEEE 2010, so 10 years back. Anyways, so what they give, that they give the semicircular ring is carrying a total charge of capital Q and is placed on a plane xy plane as they have mentioned, and the radius is r. We have to find the total electric field at point O, which is the origin of this semicircular ring. Okay, so we have taken the semicircular ring here. This is a very interesting problem. They see how they have given the problem in JEE that it is actually nourishing your knowledge base, your concepts and everything, and that is very interesting that they are fetching everything out of you. You have to remember, you have to know the concepts, you have to have some knowledge base and the formulae and everything, then only you can approach. So what they have given is this. Now let us draw the thing, this semicircular ring. We have taken a small elementary section of the circumference of the ring, which is dl, carrying a charge plus dq, and this is theta. So this elementary section, it is forming an angle d theta with the radius r as already given. So if this is the electric field for this particular elementary thing dE, then we can take components, and for symmetry of the thing from here to here, from this point to this point, when theta varies from 0 to pi by 2, we have a field to this, and from this point to this point, I mean from this section, we have a field like this. So when we take the components, the x-axis components will get cancelled, and we will be getting only the axis components which is downward, okay, minus j cap. And there will be two such things, from 0 to pi by 2 and from pi by 2 to pi, this way. So we can easily do that. So we are writing the expression for dE y, which is 1 by 4 pi epsilon naught dq sine theta by r square and minus j cap. Okay, dq by r square is the field and sine theta is the component. Great. Now we have to calculate this dq. This dq, what we are here, is can be written as lambda dl, if lambda is the linear charge density and dl is r del theta. So finally we are getting lambda is q by pi r, which is the circumference of the semicircular ring. Since they have not mentioned regarding anything about lambda, they have mentioned the total charge to be plus q. So we are writing like this, and after calculating we are getting q d theta by pi. This is dq. Now we'll be putting all these values and we'll be taking 2 of it, because as I told you there are 2 sections. So we'll be taking 2 into 1 by 4 pi epsilon naught, the total E will be integrating. So we are taking all these things out, q by pi and r square and everything. So inside it will be sine theta d theta, 0 to pi by 2 will be the limit, and minus j cap is the direction. Great. So we can integrate this, we can put the values, sine theta integration, everything we know what it is. So finally after doing all these things, we get this value as minus is for the direction, q by 2 pi square epsilon naught r square, and j cap is the directional part of the unit vector. So this is the thing, you see, this is not that way difficult. Okay, initially I was telling you that we'll be dealing with problems where we can actually see that from which concepts and from which theme they actually give you problems. Okay, now we have done ample amount of problems. Let me tell you one simple thing in this video. That is, whenever the JEE Mains, NEET or JEE Advanced, they ask question from a particular chapter or something, and electrostatics is one of the favorite chapters for the examiners. So in this section you have understood one thing, that they don't give you problems very directly where you can, okay fine, you can apply formula and you will get your answer. No. What they do, they will give you a scenario which will be, you can fetch the expression for those scenarios using the common things that you already have done in the section, and you have to apply them with a thinking capability. Like we have shown you in electrostatics also, we can have motions like simple harmonic motions. We are also seeing that we have done something for a complete ring at the center which was 0. On the axis we got something expression, we did problems. But here when they are giving a semicircular ring, here they are asking you to think that what happens if the ring is not complete. If it is complete, it is 0 at the center, but if it is not complete, we have a field, and this is the direction, and this way we can solve it. Okay, So here we have to think that how we can approach. Like here we have an approach, and everywhere we have only one elementary thing, that we take some portion as an elementary thing and then we go for the total calculation doing some sort of integration. Okay, so this is the basic concept to deal with the problems that comes in this kind of entrance examination all over India. I hope you have understood this, and I will conclude this lesson with another sum which came in JEE Advanced in 2007. That is another interesting problem, but we need not to solve anything out of it. Okay, let's check it out. It is coming next. JEE Advanced 2007, IIT JEE 2007, and this is a very interesting problem. What they have said is that two charges plus q and minus q are placed at 2 points 0, 0, a by 2 and 0, 0, minus a by 2. So it is a three-dimensional. Fine. What is the work done? They asked us, what is the work done when another charge, say q, capital Q, is moved from point A to point B, and point A is minus a, 0, 0, and point B is 0, a, 0. Okay, so this sum came in IIT JEE or JEE Advanced in 2007. We are just solving it. So this kind of problem, when they have given so many coordinates, it's better that you draw the situation and then you try to analyze instead of doing problem. Okay, first you think, visualize what is there. So we have the axis system, we have placed the dipole here, plus charge and minus charge here along z axis. You can see this is the positive side, this axis is actually towards you. So this is the front and that is the back. So minus q plus q, as they have mentioned, we have placed the charge. Now we have 2 points A and B, which are coordinates as minus a, and all this thing is written. So A, B we can understand. So we have a field for this plus q and minus q charge which will be directed along the z axis. You can understand this. It is forming a dipole and we have 2 points which will be always towards the z axis. Now when the z axis is here and you are moving a charge from A to B, which is a plane which is perpendicular to the z axis. This is the plane of A to B and this is the z axis. So eventually what happens? Cos 90 is 0. So whatever force or whatever thing, electric field will give you the force F equals to QE. So that force is along z axis and you are moving the charge on xy plane. So net work done will be 0. So this was the problem which came in JEE Advanced. Can you see? So simple it is, but it's your brain work. You have to understand the proper direction, proper orientation, and you have to visualize the situation. Then only you can say, okay, the work done is 0 because the displacement and force, they are perpendicular to each other. Okay, so here is the conclusion of this lesson. We have done many problems already. You have understood the thing. I was telling you what you have to focus on this particular thing for the entrance based on the section we have already covered. Alright, now is your part. Sit with your assignments. I'll send you assignments in our AccentUs WhatsApp group, and we'll solve those assignments which are based on this entrance part, and then we'll solve your doubts in our AccentUs WhatsApp group. Alright, till then, bye bye, stay well and utilize your time, don't waste